Work example number 8. Ratio of oranges to apples is 3:4. We don't know how many apples, don't know how many oranges, but I do know that if there are 3 oranges, there will be 4 apples. If there are 6 oranges, there will be 8 apples, so on and so forth. So I express as a fraction, number of oranges to number of apples. So let's take a look at the working. 3 oranges to 4 apples. Looks like that in a bar, in a model. Okay, so in part A, number of oranges is 3 out of 4. 3 over 4 of the number of apples. Okay. At this point, who understands the answer for part A? Understand, raise your hand. Understand, raise your hand. This is literally the answer. Number of oranges to the number of apples in fraction. Okay? Don't understand, raise your hand now. Don't understand, raise your hand. Okay, good. Thank you for your participation. So let's take a closer look at the question. They want the following as a fraction. Okay, what do they want? They want the number of oranges. Number of oranges. But I don't know how many oranges there are. Maybe there are 6, maybe there are 3, 9, 12. I don't know. But they want it to the number of apples. If it is a ratio, if I ask you for the ratio, number of oranges to apples, you can tell me easily 3:4. Right? But if I want it as a fraction, it's not difficult. Just put 3 over 4. Right? Just like our calculator. If you want to simplify the ratio, you put it in a calculator, your calculator gives you a fraction. You can convert a fraction to a ratio. You can convert a ratio to a fraction. That's what we are doing. So if they want part B, the number of oranges to the total number of fruits. In ratio, what would that look like? Number of oranges to total number of fruits. Oranges, 3. Total number of fruits, 7. 3 to 7 as a ratio. But in a fraction, what will it look like? 3 over 7 or 3 out of 7. And that's it. 3 out of 7. Now, is this difficult? No, it's just our ratio, just that we put it in a fraction form only. Okay, so I think we can skip that and we try it 8 right now. I will do the first one for you, part A. You will then do part B. So let's do part A. Lemons to oranges, 2:3. That is a ratio. So expressed as a fraction. Okay, don't worry about that. It is just like a ratio. That's why I put top and bottom only. Lemons to oranges. Lemons to oranges. So part A, expressed as a fraction. I don't need you to write so many words, just as a fraction. I want to see the fraction, that's all. Lemons, 2. Oranges, 3. Answer, 2 over 3. Done. Okay, that's literally it. So now you try part B. Part B, they want number of lemons to the total number of fruits. Lemons to total. So you think about it as a ratio. What will it be like? How many parts for the lemons? How many parts for total? Ryan, are you trying? Yeah. Okay, done. Then you can continue with part C and part D. So part B, C and D, try it now. Problem sum? A lot of words?
Yeah.
Like, okay, yeah. As long as you understand the question, the working tends to be quite simple. But the catch is that you must understand the question. So you see a lot of words, don't just think, oh, I cannot understand, my English not good. No, please don't think that way. Because if you think that way, no matter how skillful you are in mathematics, you're gone already. Okay? Tell yourself you can do it. So let's understand the question. So there are 2 people over here. Radia and Melin. They have 10 apples altogether. 10. Did they say who has how many? No, they didn't say. But we know that they have 10 altogether. Then they decided to divide the 10 among between them. The ratio 3:2. Does that mean that one person got 3, the other person got 2? Does that mean that one person got 3 apples, the other person got 2 apples? Yes or no? Why not? It's just a ratio. If one person got 3, the other person got 2, how many apples are there altogether only? 5. But there are 10, right? So it cannot be 3 and 2 only. It has to be another number. Okay, yeah, okay. So sounds like you all know how to do it. But the question is, how many apples will each of them get? Okay. So since the ratio is 3:2, the total, you can think of it as there are 5 parts. One part doesn't refer to one apple. Okay, but we know that the ratio is 3:2. So there are 5 parts altogether. One part may not be one apple. Okay? So, I think this should be quite familiar to you, this model. So there are 5 equal parts. Radia got 3 parts. Because in a question they say it is 3:2. So the first name, Radia, 3 parts. And the other person is Maylin. Her name comes next, so she gets the 2 parts. So draw the model like this. 10 altogether, 5 parts. And to know how many of them, the number of apples each of them got, we write a fraction. Radia got actually 3 parts. 3 parts out of 5. So 3/5 of how many? Of total 10. So 3/5 times 10. 3/5 times 10. You do your usual cancellation. Or if you're not familiar with this, you can do it this way. 3/5 times 10/1. Then numerator times numerator, denominator times denominator, we have 30/5, which is 6. So Radia actually got 6. Sounds like what you all mentioned just now. 3 times 2, you get 6. 2 times 2, you get 4. So one person got 6, the other person, the Maylin, got 4 of them. Okay? So the other way to find the number that both of them got is by proportion. Proportion is related to ratio. Okay? So in this case, 5 parts refer to 10 apples. I think in primary school you might have done something like this. 5 parts, they draw a dash. Then 1 part, you draw another dash. 3 parts, you draw another dash. But we don't like that. We don't want the dash because look like minus sign. Very confusing. So in this textbook, they draw a table like this. But do you remember how I taught you about the arrow, right? It is the same concept that is used over here, proportion. Okay, let me demonstrate. So how I've been teaching you and what I encourage you all to use is 5 parts represent REP, because I'm lazy to spell everything out. So 5 parts represent 10 apples. So I know that Radia, she has 3 parts. 3 parts. Then represent how many? So I draw my arrow. Okay, 10 divide by 5. Then 5, then whatever the answer is, multiply by 3. So this is what the working looks like. 10/5. So divide by 5 times 3 times 3. You can go ahead and key this into your calculator. You'll find that the answer is 6 apples. This is very powerful. It helps you in many situations. And whenever possible, I will use this again to drill it into you, to make sure you're very comfortable and confident in using this. Because it will be helpful all the way to Sec 4. Okay? So if you have not already mastered this, at every opportunity you practice. Because I know some of you have not mastered it yet. Although I've mentioned it in a few lessons. So Radia gets 6, and then the other person must get 4. Either you do it by the same way or you just take 10 minus 6. Any questions? Okay, next. Work example number 9. So we've got 2 people, they share $60 in a ratio of 2:1. 2:1. How much did each person receive? So who actually got more, Jun Yang or Raymond? Whose name appeared first? Jun Yang. So Jun Yang got the 2 parts, whereas Raymond only got the 1 part. So total there are 3 parts. How much did each of them get? So 3 units or 3 parts represent, or 3 units, they are both okay, represent $60. Jun Yang, he got 2 units. So 2 units represent 60. Okay, then divided by 3, multiplied by 2. Always do this. Very useful. Okay, so draw it in your textbook times 2. And we get $40. There's some space. Jun Yang received 40, then the other person must have received, that is Raymond, 60 minus. Sorry, Jin Yang received 40. I wrote wrongly. This is 40. Oops. Jin Yang received 40. Raymond must have received 60 minus 40, which is $20. Can? Okay, now 15 kilometers altogether. The ratio is 3:2. Find the distance that she cycles and the distance that she jogs. How many parts are there altogether? How many units? 5. There are 5 units altogether. Because cycle 1, 2, 3. Cycle. Jog 1, 2. Okay, do you have this model?
Yes.
3 is to 2. So total 5 parts. Total distance 15 kilometers. Okay, so they want to find out what is the distance that she cycled and the distance that she jogged. Okay, so let's start. How many units is represented by 15 kilometers? How many units represented 15 kilometers? So how many boxes do you see? 3, 4, 5. 5 parts, 5 units. So 5 units represent REP 15 kilometers. We want the distance that she cycled. So that is 3 parts. 3 units. Represent. Okay, so it is the same structure again. Do your division. 15 divided by 5. So divide over here, then multiply. 15 over 5 times 3. Leaving us with 9 kilometers. So these 3 kilometers, 3 units represent the cycle. She cycled 9 kilometers. She cycled 9 kilometers. Oh, what about the distance that she jogged? 15 minus 9. Oh, before we do that, did she cycle more or did she jog more? Cycle more, right? So the answer for jog must be smaller, isn't it? Minus. So? 6. How do you get 6? And jog 15 minus 9 equals to 6 kilometers. You follow the on top? What do you mean? This one is it? Yeah, it's okay as long as you get the same values. 9 kilometers for cycling and jog 6 kilometers. Do you get the same answer? Do you want me to check your presentation? Okay, come, show me your presentation.